In this section, I will discuss more graphs and displays. So we're going to concentrate on using stem and leaf plots and dot plots, as well as pie charts and Pareto charts. Scatter plots and time series plots we'll discuss in a different chapter, but I want to concentrate on these graphs here. So a stem and leaf plot is where each number is separated into a stem and a leaf. And it looks similar to a histogram. It still contains your original data values and provides an easy way to sort your data. So let's look at this small data set, and we can divide this up into a stem and leaf. So the stem in this case will be 2 for the 26, and the leaf will be 6. So as you can see, I have a picture of a little stem leaf. You got the stem over here on the left, the leaf over to the right. And you can do this for each data value. You can split it up into a stem and a leaf. So if you look at we got 21, we split that up. The 2 comes first, we put the 1 after it. We got 2 25s. As you can see, the 2 comes first in the leaf, in the stem, and you got 2 5s as leaves. Then you got 26, 27, 28. You usually write the leaves in numerical order. Okay. The next one we got 30, 36, 36. So your stem will be 3, and the 0, 6, 6 would be the leaves. And you only have 45, so your 4 would be the stem and the 5 would be the leaf. So if we're going to look at a larger data set, and it says the data set lists the number of text messages sent in one day by 50 cell phone users. We're going to put this data in a stem and leaf plot. So I'm just going to briefly explain to you again how to split it up, but we had technology actually do a stem and leaf plot. So as you can see, the largest number here is 149 and the smallest number is 16. Once again, you use the rightmost digits as the leaf, and the first digit as you can either use the first digit, depending on the number. If it's 3 numbers, you use the first 2 digits as the stem, as the leaf, I'm sorry. Okay, so we're going to list the stems right here. It goes from 1 all the way up to 14, and then the leaves come after it. You really have to pay attention to the key. As you can see, the key has 10 with the slash and then 2. That means 102. But sometimes this key can be different. This could actually mean 10.2. Okay, so always make sure you understand what the key is telling you, what the stem and leaf represent. So as you can see, you got all your data values in this stem and leaf plot. If you look here, this 1/6 means 16. Okay, this 1/9 means 19, and it keeps going. Also, if you look here, the 13 does not have a value, even though the 13 means 130, 131, 132, all the way on. But we have no data values within this range from 130 to 139. So we still write the 13, but we do not put a leaf after it. We just leave it blank. A lot of people forget to put the 13 there because they think that, oh, okay, well, since you don't have any numbers within this range, we don't use these first 2 numbers. But if you do that, then your graph will have like gaps in it, and that's not what you want. It won't be consistent. So you have to put the 13 there. You just do not put a number after it. So the reason why we say this looks like a histogram is if you tilt your head to the side, you can see a pattern. So if I do it, if you like draw, not really good at drawing sideways, but if you tilt your head, you can see a histogram. Okay? And you can see that more than 50% of cell phone users sent between 20 and 50 text messages. Okay, just by looking at that. So that's one way to display data. Typically, when you go out into the real world, you don't use stem and leaf plots. Okay, so like if you ever read a newspaper article or some type of statistical journal, you'll likely never see a stem and leaf plot. But this is a good plot to use if you have a small data set and you just want to see a pattern real quickly. You can use a stem and leaf plot. Another plot that we have is a dot plot. Once again, we usually don't see dot plots out in the real world. But to do a dot plot, you take each data entry and you plot it above a horizontal axis. So once again, we have this small data set. My horizontal axis goes from 20 to 45. And then we just plot each point above its corresponding number. So you got 21, we'll put a dot at 21. We got 225, so we stack the dots on top of each other. The same thing for 36, you have 236. So let's go back to our previous example with the text messages, and we're going to put this into a dot plot. And this will, we can use data for dot plot. StatCrunch would do a dot plot, Excel would not. But this is how your data set will look. And as you can see, it looks like most entries fall between 20 and 80. So maybe most of your data values fall within here. As you can see, this 145 is far away from the data. You would consider that an outlier or an unusual data value. So maybe this person just texts all day long, who knows. But it looks like the majority of people send between 20 and 80 text messages. Now, one graph that you'll see out when you go into the real world is a pie chart, and it provides a convenient way to present qualitative data graphically as percents of a whole. A circle is divided into sectors that represent categories, and the area of each sector is proportional to the frequency of each category. So once again, pie chart is used with qualitative data. So we can also say categorical data. Your data values are in categories. So the numbers of earned degrees conferred in thousands in 2014 are shown in this table. We're going to use a pie chart to organize the data. So as you can see, we have an associates, we have 103,000, bachelors 1,870. These are all in thousands. Masters 754,000, doctoral 178,000. That 103 thousands, that's like a million. Okay, that 1870 thousands is a million. Okay, that's over a million. 1,870,000 is what that means, but it's just truncated. So in order to construct a pie chart, we're going to use the central angle that corresponds to each category. To find the central angle, you're going to multiply 360 degrees by the category's relative frequency. So if we go to the first one, we have the associates. The relative frequency was 0.264. Remember, we calculated relative frequency to be the frequency divided by the total number of data values. In this case, we have 3,805. When we divide that out, we get 0.264. We're going to multiply that by 360, and that gives me a 95-degree angle. But remember, a circle is 360 degrees, so 95 is just a slice of that 360. When you do a pie chart, you usually put the relative frequencies or you change it to percents on the graph. So this 0.264 would be 26.4% of people had associates. Okay? And the reason why we use percentages is because if you look at this table, you just have numbers. You don't know what proportion of all the degrees are that a bachelor, how many people earned a bachelor's. We don't know that proportion just by looking at the number. Like we said, 754,000 earned a master's. Okay, well, what percentage is that of all the degrees earned? So rather than just looking at numbers, we want to look at the relative frequencies. So you can do pie charts in Excel and StatCrunch. So I've already set this up in StatCrunch for you. It's over here to the left. I have the associates, bachelor's, master's, and doctoral, and then the frequency. So to graph this, we're going to go to Graph, Pie Chart, and we're going to do with summary. This data is already summarized in the table. So when I click on it, I want categories. The categories are located in the type of degree, and the counts are located in the frequency column right next to it. Okay. I have two frequencies on here, but just ignore that second one because that's for a different problem. And then I want to do percent of total. This is going to give the percents for each one of my slices. And then I'm going to hit compute and I get this beautiful graph. Now the percents are actually on the graph is over here on the right in this ledger. So it tells me that 26.36% got an associates, and that's in the blue color. So it gives me each one, and this looks just like the one I have on my pie chart. You can also do this in Excel. I already have the uh, degrees and frequencies already set up. And remember, if you get a problem like this in your homework, you can send it over to StatCrunch or you can send the data over to Excel. So in this case, I got everything set up. I am going to go to Insert, and you'll see this little pie right here. It says pie chart. But before I do that, I need to highlight this. So I'm going to highlight the first cell. I'm going to click on it and I'm going to hit Shift, and then I'm going to highlight the rest of the cells that contain the data. So I go to Insert, Pie, and I click on it and I get my pie chart. Now as you can see, we don't have any numbers on this pie chart, but what you can do is click on, let's see, click on this plus sign. Let's see if that's the one I want. Maybe I should click on this one. Okay, no, click on this little paintbrush. If you click on the paintbrush, you'll see different types of styles come up. You can scroll through, and I want the one that contains percentages, so I want this one right here. And once you click on that, the percentages will pop up on the chart. Your ledger, it's all in color, so the blue is the associates, is 26%. The master's in gray, and that's 20%, and the bachelor's is 49%. That's the orange. Another way you can display data is in the Pareto chart. And it's like a vertical bar graph in which the height of each bar represents frequency or relative frequencies. In a Pareto chart, the bars go in order from decreasing height. So it goes from the largest, the tallest, down to the shortest. Okay, the tallest is to the left, the shortest is to the right. So a bar chart deals with categorical data. So let's look at this example here. In 2014, these were the leading causes of death in the United States. We had accidents, 136,053, cancer, 591,699, all the way down to a stroke, 133,103. So we have five categories here. And we're going to use a Pareto chart to organize the data. Okay. So when you organize the data, like I said, you have to put it from the largest amount down to the smallest, and it goes in decreasing order. So we can also do this in StatCrunch. I already have this data set up in StatCrunch. It's over here to the right, and you go to graph, bar plot with summary. The categories are the causes of death, and the frequency will be the one next to it. And when it says order by, we want to order by count descending. And when I hit compute, I get my chart. And as you can see, heart disease is the leading cause of death all the way down to stroke. The bars go from tallest to shortest. You can also do this in Excel. I already have my data values in there. We're going to go to Insert, and we are going to go to this histogram. And we're going to click on it, and if you look at to the right of it, it says a Pareto chart. Okay, so I'm going to highlight the data first, go to Insert, and then click on the Pareto chart, and there you go. And it gives you your categories along the horizontal axis as well as the frequency along the vertical axis. You have this line here, this orange line. You can ignore that. It does have, depending on what type of statistics you study, we can discuss this line, but it's not discussed in this course. Hey, this is a cumulative graph. That's what this thing is. It's an ogive. And we talked about ogives before, but with Excel, it gives you an ogive chart. It doesn't give that to you in StatCrunch. Okay. And as you can see, both of my charts look like the ones that is on my PowerPoint. Okay, that's the end of this lesson.